Inverse variation. This is when we're comparing two quantities, and as one quantity increases, the other decreases. So as one goes up, the other goes down. Inverse variation. So how we're going to set these up is we're going to compare the two quantities, and then we're going to have to flip one of them to create that inverse effect. So for example, if two people take 8 hours to construct a deck, how long would it take if there were 4 people? How long would it take if there were 4 people? Okay, so this is kind of one scenario where this happens, that the more people you have working on a job, the less time it should take. Now this one I picked to be one that maybe we can use some common sense to see what my answer should be. Because if it takes 2 people 8 hours, if we double the number of people, okay, so we're doubling how many people, it should cut the time in half. So our answer should be 4 hours if we just kind of think about this logically. So now let's see though how we would solve this if the numbers weren't so nice. So the two things we're comparing the number of people and the hours it takes to do the job. So I'm going to line things up like I would with a direct proportion first. So 2 people takes 8 hours. I'm going to put that on top. How long would it take if there were 4 people? So 4 people, I don't know how many hours. So now I have to flip one of the fractions, and I usually just always do the second. So I'm going to change this to x over 8. So when I cross multiply now, 2 times 8 is 16 equals 4x. Divide by 4, and x equals 4 people, just like we figured out rationally. Okay, now one thing I want to note is when we do this flipping and do the inverse variation, and we set it up, line it up like direct, and then flip, we have to line things up as columns. Like people and hours were the two quantities we were comparing, so we have to have those be our columns that we're lining up. Okay, how about this one? So for this one, a gear is 10 inches in diameter and moves, let's say right now it's moving 350 RPMs, revolutions per minute. If it's attached to another gear, that's 4 inches in diameter, how fast is that gear turning? How fast is that gear? So here's another one that the size of the gear is going down, which means it should have to turn more times to keep up with the bigger one. So the two things we're comparing here is the inches, the diameter, or inches, and then the speed, the RPMs. Okay, so if the diameter of 10 is going 350 RPMs, so I'm putting those on top, then a gear that is 4 inches diameter, what is the speed? I don't know that. So I'm going to do my flipping and make this still 10 over 4, but now equals x over 350. So when I cross multiply, I'll have 3,500 equals 4x. And when I divide by 4, I'll get 875 RPMs, revolutions per minute. Okay, another situation, just to kind of talk about the different possible situations, would be speed and time. Like if I drive faster, it should take less time to get somewhere. So that's another example of where we would have to set up an inverse proportion. But